Okay guys, in this video we're going to look at our first set of matrix operations, and that is to say that, with real numbers we have operations, and these are commonly used: addition, subtraction, multiplication, and division. It is the case that with the set of matrices, not necessarily all of those operations are defined, but some of them certainly are, and those basic three that we're going to look at in our videos are going to be addition and subtraction, which are going to be covered in this video, and then scalar multiplication, which I'll cover very quickly in the next video. But these basic operations exist, and we're going to be using them from time to time. So let's take a look at addition and subtraction, which are pretty easy operations to carry out with matrices. We say that addition of matrices is only defined if they have the same order. So if you're highlighting things here, this is one very important thing that we want to know. And you know what, I'm going to go ahead and read this for subtraction as well. Subtraction of matrices is only defined if they have the same order. So that is to say that if you ever try to add or subtract two matrices that are not the same dimensions, okay, you would just write undefined, okay, or a dimension mismatch. So we say we add matrices by adding entries that are in the same row and the same column in each matrix, and likewise we subtract matrices by subtracting entries that are in the same row and the same column in each matrix. So what we're going to do is just look at a few expressions down here in which we'll use the same A and B matrices that I've given up here. Looks like we have a couple of matrices. Let's go ahead and write their orders in the bottom right hand corner. It looks like they're both 2 by 2, and so with all of these expressions that we're going to evaluate for here, matrix A plus matrix B, or A minus B, or maybe A plus itself, A plus A, or even A plus B plus A, we're going to be adding or subtracting with these two matrices that are both 2 by 2. So in every possible instance here, we're going to get defined sums and differences. Now, how I would write this for A plus B is simply, I would just write it out. And so we're going to write matrix A here, which was a -1, 3, 3, 7. And we're going to say that this is plus now matrix B, which is -2, -3, -10, and 5. So instead of A and B here, we just substitute straight into the expression our matrices. And so what we get is this new matrix, and rest assured we say that this new matrix is a 2 by 2 matrix. Now I'm going to show my work on this first one, but going forward I'm going to say we could just do this mentally. Basically, we're going to take -1 plus -2 to get our new entry in this top left corner. So essentially this new entry is -1 plus -2, because those were both the entries in both of those rows. If we go over to the first row, second column, well, that would be this and this. We would say this is 3 plus -3. If we go down to the second row, first column, well, the second row, first column, plus the second row, first column would be 3 plus a -10 here. And then our second row, second column, which would be this 7 plus the 5, we would just say it's just, 7 plus 5. So showing my work, this is essentially what we're doing here. We're just adding up all the entries that occupy the same positions. But what we get essentially is -1 plus -2, which, is -3. Here, 3 plus -3, we're going to get 0. 3 plus -10, this 3 plus this -10 would be -7. And then 7 plus 5 would be a 12. So essentially, these are pretty quick to get. You don't have to show this work right here, but I did want you to see where I was coming from on this one. So let's take a look at letter B. Letter B, as a matter of fact, is a subtraction problem. So we're going to talk a little bit about how you might handle this and my suggestions, okay? So we see that we have a subtract sign here, -2, -3, -10, and 5. So I'm going to write a piece of advice here. Basically, let me put it up here, and you'll want to write this down in your notes. But basically, okay, here we go. Whenever subtracting, we'll rewrite as adding the opposite. And that is to say that we'll act like we're distributing a negative throughout a set of parentheses, which we've kind of looked at before. Whenever you have a negative in front of a set of parentheses, right, you tend to make it a positive and switch everything on the inside. So when we look at something like this, it's not that you cannot subtract straight across. As a matter of fact, we are going to get this new 2 by 2 matrix. 2 by 2 minus 2 by 2 is a 2 by 2. But what I want you to see is, instead of trying to do -1 minus a -2 in our heads here, let's go ahead and take this negative that you see right here. We're going to change it to a plus, but we have to add, add the opposite. So we're going to make everybody in here the opposite of what they started as. And so it looks like this now. And so, now this just becomes addition all of the time whenever you think about it, because we're going to change subtraction to addition anyway. So we say -1 plus a +2. Well, easily that's a 1. If we said 3 plus 3 here, we'd get a 6. 3 plus this +10 would be a 13, and then 7 plus a -5 here would be a 2. And so this would be our difference right here, A minus B. So now looking at a plus a, some interesting things go on here. We're going to look at scalar multiplication in the next video, and we can talk about how this would be the same thing as 2a, but we say a plus a, naturally, you know, combined like terms would be 2a. But what do you think that's going to do to all the entries in this matrix here? So we have negative 1, 3, 3, 7 plus negative 1, 3, 3, 7. If I were to add these two 2x2s together here, then I would get a new 2x2 sum. And this new 2x2 sum would just be negative 1 plus negative 1 is negative 2. 3 plus 3 is 6. 3 plus 3 is 6. And then 7 plus 7 is 14. We would just get this as our sum here. And I would ask you to think about, well, you know, if this really is 2 times a, then what really happened to all the entries in the matrix here when we take them times this 2 out in front? So that's a good foreshadow for our next video. But this last one here, let's just go ahead and put it together. And I just want you to see how this would work. Essentially, when you're adding more than 2, I guess, you know, terms in your sum, we'll just go ahead and populate them with what they are here. We'll go ahead and make our substitution. So a is negative 1, 3, 3, 7. B is, looks like negative 2, negative 3. And then negative 10 and 5. And then we're going to repeat a over here. We have negative 1, 3, 3, and 7. Just like we would before, you know, a 2x2 plus a 2x2 plus a 2x2. What we're going to do is we're going to go ahead and add corresponding entries. So straight across, negative 1 plus negative 2 is negative 3. Negative 3 plus negative 1 is negative 4. So our new entry here is a negative 4. And then we'll say, okay, well, how about 3 plus a negative 3, which is 0. 0 plus 3 is 3. 3 plus a negative 10 is negative 7, but negative 7 plus a 3 is a negative 4. And then last but not least here, second row, second column entries, 7 plus 5 is 12, and 12 plus 7 is 19. So we get this 2x2 matrix here as our sum. So adding and subtracting, pretty easy thing to do. You just add or subtract component-wise, and just remember that they have to have the same order. Otherwise, you get to be done, and you get to just write undefined. Cheers.